Hello everyone. So now let's see a small example of k-means clustering. Okay, so now we have a data set given in which we have some instances, we have their x and y coordinates. Now x and y are like features, you can say. Okay, so for example, if we talk about, let's say, iris flowers. Okay, so this can be, let's say, the petal length, and this can be, let's say, the sepal length. Okay, and based on this we want to classify the different iris flowers together. Okay, and let's say the length is in, let's say, millimeters. Okay, so let's say the first instance has petal length as 185 millimeter and sepal length as 72 millimeter. Okay, second one has 170 and 56. Third one has, let's say, 168 and 60. Fourth one has 179 and 68. Fifth one is 182 and 72. Sixth one is, let's say, 188 and 77. Okay. Okay. Now the basic concept of k-means clustering is the points which are similar, okay, the data points that are similar to each other will be closer. And how do we define closer? We define that using the Euclidean distance in case of k-means algorithm. Okay, so firstly we have to begin somewhere. So we randomly assume that this is our centroid k1 and this is our centroid k2, and now we will measure how many points are close to k1, they will form the cluster of k1, and how many points are close to k2, right? So these will form the cluster of k2. In case of k-means, the clusters are roughly circular, or if you are talking about 3 attributes, then spherical in shape. Okay, in this case we have only 2 attributes. Okay, so Euclidean distance, all of you know how we calculate that. So what we have to do is, now we have to calculate the distance of third point onwards. Okay, so for anyone who has forgotten what Euclidean distance is, basically Euclidean distance d of xy, let's say, is equal to square root let's say d of AB, because it will be easier to write it that way. So you can say a dot x minus b dot x square plus a dot y minus b dot y square. Okay, if a and b are 2 points and we want to calculate, or 2 data points basically, so we'll find the difference between their x attributes and square it, difference between their y attributes and square it, add those squares, and then take the square root of the entire thing. This is the square root of the entire thing. Okay, so this will be the Euclidean distance. Now we'll have to calculate Euclidean distance starting from the third row onwards, right? Delete this. Okay, so here itself I will add a column for, okay, distance from the centroid C1 and distance from the centroid C2. Okay, so now for the third point, distance from C1, you can pause and calculate for yourself. You need not simplify it further. You can leave it at square root 433. Here you can leave it at square root 20. Here you can leave it at square root 52. Here it will be square root 225. Here it will be square root. What are we? Okay, let's calculate this one. So to understand what we are calculating exactly, when we are saying distance from C1, okay, what we are actually calculating over here is, so So this point is 182 and 72, right? So we are saying 182 minus 185, because for C1, that is the centroid is K1. C1 is the cluster C1. Cluster C1 is represented by its centroid K1, right? So distance from the centroid of the cluster C1, 182 minus 185 square plus this is 72 minus 72 square, and then the square root of that. So this comes out to be square root of 9. Okay. Then for the last one, 188 minus 185. This is 188 minus 185, and this will be 77 minus 72. So this is 3 square plus 5 square, which is 9 plus 25, which will be square root of 34. Similarly, when I am calculating for this one, what I am doing is 182 minus 170. 182 minus 170, because K2 is the centroid, right? So when I am saying distance from a cluster, I mean distance from its centroid. So 182 minus 170 square plus 72 minus 56 square. Okay, so this is 12 square plus 16 square. This will come out to be 400, right? So this will be square root of 400, which is 20 in fact. And for the last one, it will be 180. So 188 minus 170 and 77 minus 56. So this will be 18 square plus 21 square, right? So this will come out to be 765. Okay, and now for each one of them we have to make a decision which cluster will it go to. Okay, so which is the lesser distance? This is lesser distance, so we can say 0.3 is closer to the cluster C2, so it will go to C2. 0.4 is closer to the cluster C1, so it will go to C1. 0.5 is closer to cluster C1, so it will go into the cluster C1, and 0.6 is closer to the cluster also C1, so this will also go in C1. Okay, so roughly you can say that your cluster 1 has the point 1 itself, and it has the point 4, 5, 6, not accurately drawn as per space, just as a representation. C1 is this, and C2 is the point 2 itself, and just one more point, which is the point 3. Here you have 1, 4, 5, 6, these many points are there. Okay, so now let's refresh all the calculation. Okay, I'll erase some things. Okay, so let's remove this part. Because now we want to calculate something else now. Okay, so now initially I had assumed the point 1 and point 2 to be the centroids of the cluster, right? Now once I have this calculation in hand, okay, see, now I know that the points in cluster 1 are 1, 4, 5, 6. So I cannot simply say that 1 is still the centroid of this cluster. Now the centroid will be updated. So your next logical step is to update the centroid. Okay, now we'll update the centroid. When you update the centroid, that means for C1 the update will look like this. Okay, basically x1 I'll call as the x coordinate of the new centroid. This is equal to the x coordinate of 1 plus x coordinate of 4, right, plus the x coordinate of 5 plus x coordinate of 6 divided by 4. I am taking the average. Okay, and the y coordinate, let's say y1, will be the sum of the y coordinates. So 1 y coordinate of 1 plus y coordinate of the fourth point plus y coordinate of fifth point plus y coordinate of the sixth point, and everything of that divided by 4. Okay. So now if we calculate this, this will come out to be 183.5 and 72.25. So this is our new centroid. Is this an actual point in our data set? Not any longer. Not any longer. Okay, so for the first iteration we took two existing points just to begin with somewhere, right? But now once we have calculated and updated the centroid, now this need not be a point in our data necessarily. Similarly, C2, how will you calculate C2? You will take the average of x coordinates of 0.2 and 0.3, that is 170 and 168. Average, I can simply say that 169, y coordinate average will be 64, straightforward. Sorry, 56 and 60, this is 58, yes, this will be 58, right? So these are the new centroids now, C1 and C2. Now what will I have to do? Instances and points still remain the same, so I'll select all this part. Okay, so now again we'll have to make this decision. Now, okay, 168, okay, let's calculate once again. Okay, now we'll have to start from point 1 itself. So 185, okay, so distance of point 1 from C1, this will be square root of 183.5, okay, 183.5 minus 185 square plus 72.25 minus 72 square. Calculate this, this will come out to be 1.5207, and DC2, I'll erase this part as well. I'll just fill the values over here, but you can pause and actually calculate the values using the Euclidean distance. Okay, what I want to illustrate now is how do you progress or how do you stop in this algorithm. Okay, for the second one it will be 12.961, here it will be 2.2361, here the distance will be 19.7563, here you have 6.1857, here you have 14.1421, here you have 1.5207, 19.105, this is for this point. Okay, and for the last point you have the calculation 6.5431, 26.8701, and now make the decision which new cluster will it belong to. Okay, so now again, so you can see that point 1 is closer to cluster 1, so C1, point 2 is closer to cluster 2, point 3 is closer to cluster 2, point 4 is still closer to cluster 1, point 5 is still closer to cluster 1, point 6 is still closer to cluster 1. Okay, and now if we compare which clusters did the point initially belong to, 1, 4, 5, 6 belong to cluster 1 and 2, 3 belong to cluster 2, and they still belong to the same cluster. Now we will not continue any further. That means our cluster assignment has not changed. Okay, in the previous iteration when we drew the table, the points belong to the same table, and every point belong to the same cluster. Okay, every point belong to the same cluster. In this new iteration, every point belongs to the same cluster as it did in the previous iteration. So therefore we can stop at this point. Okay, and we can say that this is the final cluster assignment. That's your answer for k means. Okay, going further in real life, you have some interpretation that you can come up with. So for example, in case of flowers, can we say that 1, 4, 5, 6 belong to the same subspecies, or they belong to the same variety, or 2, 3 belong to some other variety, or you can basically create classes. You can create class labels based on clusters where species or subspecies can be the label. Okay, so that's it for the k-means. If you have any doubts, do post them in the comments below. Thanks for watching.